Alright, Algebra 2 Trick Honors students. We'll talk about that, the continuation of Chapter 8 once again. So this one is Part 3. So the way to find out the geometric series. So last time we talked about the way to find out the sum of the arithmetic series, but now it's the sum of the geometric series. And as you can see that this one is all written in terms of sigma. So anytime that I see that the geometric series written with the sigma notation, so this one it's considered a structure of sigma with k equals 1 to the value of k. And then it's normally written as a sub 1 times the common ratio to the power of k minus 1. If you try to compare that the basic geometric sequence formula, which is a sub n equals a sub 1 times the common ratio to the power of n minus 1. So basically that's the structure of the sigma. So it's, well, looks like they're exactly the same kind of element given here. A sub 1, common ratio, n, but instead of using n, we're using k. So the way to find out the sum. So there's another formula for this. So let's talk about that right here. So the way to find out the sum of any geometric series so the way to do that is by using sigma. Well, instead of using sigma, we're using a sub 1 times 1 minus r to the power of n, and then it's all over 1 minus r. Okay, so let's use that formula. So a sub 1, once again, the number of the first term, r, which is the common ratio, and then it's the number of term. Okay, so now let's go back to the problem. So what we found here, compare and contrast. So a sub 1, if the number is not shown right in front of that base, it's always 1. Common ratio, that's just the base, which is 4. And then n here, which is what? 10 to the 10th terms, okay? So using that formula, so the sum, a sub 1 times 1 minus r to the power of n, all over 1 minus r. Okay, you can put in parentheses for the whole thing here if you want to. So a sub 1, so what we got is 1 times 1 minus the common ratio, which is what? 4, to the power of n. N is 10. And then all over 1 minus the common ratio, minus 4. So what we found here, so this one you just put it out, so 1 minus 4 is negative 3, so negative 1/3, times 1 minus 4 to the 10th power. So this one you probably want to do that on the calculator. So using the Google calculator, 4 to the 10th power, so 4 to the power of 10. Okay, so there should be a little caret here. Okay, that's just a scientific notation. Okay, let's see right here. Okay, let's cross out the inverse. Okay, the little caret, so 4 to the power of 10. So that one is 104. Well, it's actually 1,048,576. That's a big number. So 1,048,576. So it's 1,048,576. So once you subtract, you'll get the negative number, and then divided by negative 3. So this one, okay, going back to the calculator, it's better for you to do that on the calculator because that's a big number. So we found out that one, so it's 1,048,576, and then subtract from 1, minus 1, and then times negative 1. Well, negative over negative is going to be positive, so that number divided by 3. So eventually it's going to be 349,525. 349,525. So try to do that on the calculator. So, and that's the sum of this geometric series from the first term to the 10th term. Well, because that once you multiplied it out, it's exponentially growth. So that's why the number is getting bigger and bigger. But once you need to add those terms together, so the number would be considered a huge number. Okay, so now 36. So let's check that. Okay, yeah, that's what we got. So 349,525. So now, to look at that, another one. So sigma, and this one, k equals 1 from the first term to the 7th term. So that means n equals 7. Compare and contrast. So a1, it's considered 1. And then the common ratio, it's negative 3. Okay, sorry. And now, let's see what else that we have. Okay, so basically just plugging those three elements and a sub 1 common ratio. So for the sum, we do have a sub 1, which is 1, times 1 minus r, negative 3 to the power of n to the power of 7. And then this one is all over 1 minus negative 3. And now we want to put it into the calculator. But before you do that, so this one can simplify it a little bit. So it's 1/4 times 1 minus negative 3 to the power of 7. Well, we do know that it's going to be negative, but negative times negative is going to be positive. So 3 to the power of 7. You can just put that then to the calculator. So 3 to the power of 7. And then plus 1. And then after that, let's see what else that you have right here. Divided by 4. So the sum is 547. Okay, so check that. So this one, 38. Yeah, 547. So now, what about for the rest of this? So for number 40, and this one also you want to find a sum. Well, the things that we do know that a sub n, well, let's see the instruction here. So it looks like this one you want to find out, oh, you know what, n is missing here. So in order to get n, we need to use the geometric formula, the geometric sequence formula, which is considered a sub n equals a sub 1 times common ratio to the power of n minus 1. So a sub n is given, it's negative 39366. It's a very small number. A sub 1 is negative 3. Common ratio, that's 2 to the power of n minus 1. So in order to get the sum, you need to know what n is. So besides getting to know that a sub 1 common ratio, but also the value of n. So what we found here, so negative 39366, so negative 39,366 divided by negative 3. So once you divide it, so that would be negative, let's see, negative 13122. So you just divide it by negative 3. Positive, excuse me, because negative over negative, then that would be positive. To the power of 2 times 2 to the power of n minus 1. And we do know that the base is 2, so this one, you might be considered doing like the change of base or convert that to the log form. I mean, certainly you can do things like that. And other thing perhaps you might be considered doing, so you want to change this one to the common base. So this one would be kind of a difficult common base. So let's say that it's so the easy way that I do recommend you to do it, it's just simply take the log, convert that to the log form, using that the previous concept, things that you learned from the previous chapter, chapter 6. So convert that to log, you do have log base 2. Well, even we can convert that to the common base 2, but we don't know what the power is. It's a big number. So log base 2 of 13122. So that equals n minus 1. And then from here, we can use the change of base formula. log of 13122 divided by log of 2, and then add 1 so we can get n. Okay, so let's do that on the calculator. So log 13122. So log 13122 divided by log of 2. Okay, make sure that you need to separate that, the division and the parentheses. Divided by log of 2. And then what else do we need to put in for this? Plus 1. Okay, so just add 1 mentally. Yeah, but somehow this one come up with like a decimal. It's supposed to be an integer here. So let me check this one. So for the value of n, it's supposed to be integer. It's not a decimal here. So once we divide it, so negative 39366. So positive 13122. Okay, so what we did, we convert that to the change of base. Okay, one more time. Log of 13122 divided by log of 2. So using the change of base formula. Okay, let's put in parentheses. Log of 2. Interesting. And then add 1 there. Then that'll be 14. Okay, let me check this one real quick. Oh, you know what? I think I messed up with this right here. Apologize for that. Okay, so that happens all the time. So no one's perfect. It's hard to be perfect. So now let me just start it, because what I did, I swapped the common ratio and a sub 1. So that's why I end up with completely different result. Apologize for that. So basically this one right here, so a sub n, so that's right. It's negative 39,366. But what I did, I put in a sub 1 as negative 3. That's why. Okay, so let's just reset it. So negative 39,366. So that equals a sub 1, which is 2, times the common ratio, negative 3 to the power of n minus 1. Here we go. So once you divide it, so this one's going to be a negative number. Okay, so negative 39,366. Divided by 2. So we get negative 19,683. So negative 19,683. And then this one is negative 3 to the power of n minus 1. So again, this one can use that to convert that to log form. So it's log of base negative 3 of negative 1,000 963 to the, so that equals n minus 1. So from there we can use that to change a base, but log of a negative number, then that would be considered, okay, so that would be considered error. So what we can do, we can always convert this one as a common base. Okay, so let's just verify that. So negative 3 to the power. So you try to use the change of base form. So for the negative negative, you need to get rid of the negative. But you just put in log of negative number, then that would be considered an error. So what makes this number as negative 19,683? So let's check that. So 3 to the 14 power. That's too big. 3 to the 11 power. Okay, that's pretty close. Well, actually that's considered small right here with this number. Okay, so let's think about it. So try to use that, the factor tree divided by 3. So maybe, let's see, 8 times. So 3 to the power of 8. Three to the power of 9. Here we go. So this one can be written as negative 3 to the power of 9. Well, it cannot be 8 because that the result is positive if that's 8. So negative 3 to the power of 9. So that means n equals what? 10. So once we solve for n, so we can use that the summation formula to find out the sum of this geometric series. So the sum, then that would be considered a sub 1, 2 times 1 minus r to the power of n, negative 3 to the power of n, negative 3 to the power of 10. And then it's all over, 1 minus negative 3. And then the rest of this, you want to do that on the calculator. So 1 minus 3, 1 minus negative 3, then that would be 4. So 2 over 4, then that would be 1/2 times 1 minus negative 3 to the power of 10. Or just basically 3 to the power of 10. $59,049. Subtract 1 and then divide it by 2. So eventually it's going to be a negative number. Okay, so subtract 1. Then divide by 2. But we do know that's a negative number. So negative 29,524. Okay, let's see. So negative 29,524. Okay, so check this one, number 40. Yep. So gotta be careful the way to put in that the setup. Okay, so the next one is quite similar, but you need to solve for n first. So try to solve for n. It's a big number again. Okay, so now what about for 44, 46? So how do we find out the sum of this kind of a geometric sequence? Okay, so we do know that n is 7. A sub 1, it's negative 1. And then this one is just like minus, minus. So basically just like adding negative number together. So the next term is what? Negative 4. Negative 16, negative 64. So eventually the sum is going to be a negative number. So for a sub 1, we do know that it's not a sub n. It's a sub 1. So find out the common ratio. So the common ratio, then that would be considered what? 4. So negative 1, in order to go from negative 1 to negative 4, we multiply by 4. So we got a sub 1, we got r, we got n. So put it into the formula. So s sub 7. So a sub 1 is negative 1. So 1 minus r to the power of n. So 4 to the power of 7. And then all over 1 minus 4. So 1 minus 4 to the power of 7, well, this one again simplified it. So negative 3, negative 1 over the negative 3, 1/3. 1 minus 4 to the power of 7. So 4 to the power of 7. Subtract 1. But that number is going to be negative. So multiply by negative 1 if you want to do that. Okay, and now let's see what else. And then divided by 3. Multiply by 1/3. That means divided by 3. So negative 5,461. So negative 5,461. And that's the sum of this geometric series. Okay, so 44. Yep. And then the next one, it's quite similar. Okay, so find out that a sub 1, which is what? 1. Common ratio, which is 5. And then n is 6. So basically just plug in a number. So that way you can do it on your own. And now the next type of problem, determine the number of the term n in each geometric series. So what we got here is the sum of the geometric series. But the things that we need to figure out what n is. So basically this one, just plug in a number to the same formula. So s sub n equals a sub 1 times 1 minus r to the power of n all over 1 minus r. So the sum is given already. It's negative 21. A sub 1 is also given. It's negative 3. So 1 minus the common ratio, which is what? 2 to the power of n. And then this one, it's all over 1 minus the common ratio. So 1 minus 2. So negative 3 over negative 1. So then that would be 3. Okay, so try to simplify the equation a little bit. So what we got here is negative 21. So that equals negative 3. No, positive 3. So 1 minus 2 to the power of n. So negative 21 over 3, then that's negative 7. And now, another thing that we can do is subtract 1 both sides. So we do have what? Negative 8. So negative 2 to the power of n. Negative, negative, cancel. So we got a equals 2 to the power of n. So that means n equals 3. So the other one is quite similar. So negative 185, which is the sum of the entire series. A sub 1 is 1 times 1 minus the common ratio to the power of n. Got to be careful with the sign change. There's so many negative, negative. Got to be careful with those negative sign. Again, this one times. And then 1 minus negative 6. So this one, 1 minus negative 6, then that'll be 7. So it's 1 over 7 times 1 minus negative 6 to the power of n. So that equals negative 185. Multiply by 7 both sides. So 185 times 7. But it's going to be negative. So 185 times 7. 1,295. 1,295. So that equals 1 minus negative 6 quantity to the power of n. Subtract 1 both sides. Again, this one's supposed to be negative. So subtract 1, so you got negative 1,296. So that equals negative 6. Well, that equals negative, negative 6. Again, so got to be very careful with the sign change. Negative, negative 6 to the power of n. So negative, negative got canceled. So 1,296 equals 6 to the power of n. And let's see what n is. So we do know that 6 to the third power, it's like 200 something. So this one, maybe 6 to the fourth power. Okay, let's find out. Oops. So 6 to the 4th power. Yep, 6 to the 4th power. Oops. So 6 to the 4th power, so n equals 4. All right. So we solve 48, we solve for number 50 for the value of n. And then for the rest of this, we'll continue that with the other part of the lesson. The 4th part of the lesson, you'll see that later today. All right, so I'll see you guys next time.